Professor Schmitt is Professor of Information Architecture at ETH Zurich. He's a lead principal investigator of the ETH Future Cities Responsive Cities Scenario. He's also the founding director of the Singapore ETH Center in Singapore, and ETH Zurich Senior Vice President for ETH Global. Professor Schmitt holds a diploma in engineering and Doctor of Engineering degree of the Technical University of Munich, and a Master of Architecture from the University of California, Berkeley. Now, his research focuses on urban metabolism with the associated emissions, smart cities, linking big data with urban design, urban models, simulation, visualization, everything that you want to know about the use of information for smart city research. So he and his team developed and taught the first massive open online courses on future cities and livable cities. Now, from 1998 to 2008, he served as Vice President for Planning and Logistics, a member of the board of ETH Zurich. He directed the development of ETH's strategy and planning in cooperation with the 16 scientific departments. From 1984 to 1988, he conducted CAAD research and teaching at Carnegie Mellon University. He joined ETH Zurich in 1988, and he was a visiting professor in a number of universities, including Harvard. So Professor Schmitt initiated and conceptualized the sustainable ETH Science City campus in Zurich, and he received for his work in 2010 the European Culture of Science Award. So Professor Schmitt has expertise and phenomenal experience in smart city research. So may I invite Professor Schmitt?
Thank you very much for the introduction, and thank you very much for the invitation. I was also highly impressed by the previous talk by Louis, and being one of the super creative people like all of you, I'm also super jet lagged, so please forgive if I'm a bit slow sometimes. I first want to introduce my team. This is the team in Zurich, at ETH Zurich, part of the team, and this is the team in Singapore, working together on this big topic of responsive cities. What are you in for today? I will talk about smart buildings at the beginning a little bit, because smart buildings are very important for smart cities, of course. Then our major goal is to achieve responsive cities and the role of big data in the planning and design of those responsive cities. It's wonderful that we got so much factual information in the last talks, because that shows already direction, what we are dealing with in the urban question, 2 to 2.5 billion more people in cities in the next 20 to 25 years, and the majority of these cities coming up most likely in Africa. Where do I come from? This was the picture from my house when I left 2 days ago. And so it is very cold where I come from at the moment. And that already is an indicator how different the perception of smartness is in different parts of the world. We never should forget that. I'm going to say some critical words, of course, about smart cities, smart houses. At the same time, I want to say that I'm fully enthusiastic about this concept. I'm living within this concept here. For example, I took this image yesterday in the lecture here. You can see that the date at the bottom, but these are the controls of our smart house through the app. And when my wife called me to say it was too cold, I could make it a bit warmer from here. So these are the normal things we can do today with smart houses. I also think it's a very good thing to have smart transportation, zero-emission smart transportation with our cars here. And looking at this map, I noticed again that the temperature was minus 1.9 degrees in the car yesterday morning. And I also noticed, because our family of 5 shares everything, of course, I also noticed that it must have been my daughter who was at her boyfriend's house, as you can see in the red dot here. But these are the things that are normal today, and I just want to try to connect the personal experience to what I'm teaching as much as possible. So let's have a look at buildings and smart buildings, buildings from the analog time, many thousands of years ago until today. And there are a few key characteristics of buildings. Architecture, prestige was very, very important. Security and safety, of course. Comfort, performance, and control. A rough order, I admit this is the Middle European assessment of buildings and their important features. But if you look at smart buildings today, this order has changed quite a bit. Suddenly, control is the new prestige. People are more talking about the control systems they have in their house rather than the architecture of the house. Security and safety are still quite important. Comfort as well, performance as well. But design, for some reason, unfortunately, has gone back quite a bit. It's coming back up again now, fortunately. And already in 2003, 13, 14 years ago, the UK Department of Trade and Industry came up with the following definition of a smart home. It's a dwelling incorporating a communications network that connects the key electrical appliances and services and allows them to be remotely controlled, monitored, or assessed. So this was a very technological definition, and this is also the origin of the whole smart home, smart city development in the early part of this century or millennium. Here, at least in this building, you can see certain parts that people are using, but in the next schemes, the more modern smart home descriptions, you find nothing of people anymore, not even furniture, let alone people themselves. Actually, this is the smart home that I have installed, which I'm running, and you can see every single part of the performance you can check from other places, other countries. This is also a snapshot just from this morning. But smart is often not so smart. You may have experienced as well the smart sunshades. That's the first example people always bring up. This is a building at ETH, our university. Beautiful tree. And behind it, building from the 60s with smart sunshades. And although they should somehow react in the same way, you can see they lead a very individual life, and quite often they don't do what you expect them to do. And that led many people to the conclusion that Kent Larson, for example, from MIT Media Lab, I don't believe in smart homes. That's a kind of a bogus concept, was his conclusion. We don't want to draw the same conclusion for smart cities. But when we move from smart buildings to smart cities, there are some similarities. So on smart buildings on the left side, and then smart cities on the right side, I tried to make some connections. So control, prestige in smart buildings, very important. In smart cities, safety and security are always put at the front. Then security and safety in buildings is number 2. In smart cities, services, all kinds of new services that people don't even know about it yet, are put into the front. Then comfort in smart buildings, performance, very important in smart cities, and then performance in smart buildings and comfort, they're kind of interchanged. And the design of buildings and urban design are at the same place. So far, so good. But what does it do? In the end, smart cities consist of smart people, of course, and smart buildings. Buildings sometimes are not so smart, or they overdo it a little bit here. As in Singapore, of course, it's quite hot, but still, is that the building you want to live in? How comfortable, how livable is that? Or communication is important, electricity is important, but does it have to be done this way? This is a picture, of course, could be from the United States, or could be from Germany, or could be, in this case, it's from Vietnam. And this is the big data flood or tsunami that many people are talking about here at Imperial College in London, visualizing the transportation system of Shanghai and making available all kinds of visual information to people. But what we are really interested in, what we're really after, at least in our context, is livability and make cities more livable. So smartness is not an issue or a deal or a goal in itself, but it's a means to an end of more livability. And we saw from the presentation before that the inequality or the equality, Gini coefficient are important, and the most livable cities, at least to the according to the rankings of the most livable cities, they all show a relatively low Gini coefficient. That means the difference between poor and rich is relatively smaller than in those cities that are less livable. And most livable cities have efficient local good governance. This is very, very important. No matter where they are, they're rich or poor, the local good governance is important. So smartness and livability are not a contradiction, but one or the other alone is not enough. The livability is also not restricted to high-tech countries or high-tech places. There are beautiful places on earth here in Myanmar where livability in some areas is quite high, or some places which are not cities but villages, like this one here in Zermatt, the Matterhorn, where livability is extremely high, or places like Zurich where landscape, water, city, all are mixed in a very unconventional way for a modern city. Or here, the most livable city at the moment, or for the last 5-6 years, on this picture, Vienna, where the inhabitant seems to be quite happy to live, but you can see lots of cars and no people on the street. And look at this type of architecture, very similar type of street and architecture, something that Europeans love or would love to have actually here in Myanmar, in Yangon. So it's not a matter of rich or poor. We think of it's many other factors that are important. And I asked Professor Lee for his permission to use the slide from yesterday, which I took because I was impressed to see the motivation and goal of the smart city in China, and to get at the bottom line to realize the Chinese dream. And there are even the criteria which are listed, which I find really great. And just to make the point how different sometimes it is in different countries, we put the Chinese dream on the left, Professor Lee, and the Swiss dream on the right. And I tried to relate each one of the words to the other one. So urbanization, we are urbanized in Switzerland, so we are really striving for more livability. Industrialization, of course, we are talking about industrialization 4.0, but I think that's not enough, so it will be 5.0, 6.0, whatever. Informationizing, we see the biggest problem now to domesticate big data, not to create more, but really to domesticate it. Everything Professor Lee showed yesterday is quite impressive, but for us it shows that it's necessary now to take control of the big data rather the other way around. Low carbon, on one side we totally agree, we even want to decarbonize completely. And green, total agreement, green is green. This is wonderful. And sustainability, we think we can only achieve sustainability in the long term if we go for responsiveness first. And that's what the major part of the talk will be about. Okay, so also I said I want to connect the personal experience to what I say in class. And this is something I'm really not proud of. I should be ashamed of it. But I thought I just put it up here. It's a rough estimation about the CO2 production of my family, of these 5 people in the last 20 years, year by year. And you can see here the blue at the bottom is the hot water, the CO2 that was needed to produce the hot water for the house. And the top is the heating, CO2 needed for heating. And what you see at the end, in the year 2016 and 17, heating goes down dramatically. And that has a good reason. Then I added on top of this the cars that we're using. And the cars that we were using, living in this place that you saw in the beginning, on the top of a mountain, going up and down all the time, using this green part, lots of CO2. And I'm really ashamed because you see this family of 5 people produces almost 25 to 30,000 kilograms of CO2 per year. But also you see, after being in Singapore for a while, seeing how you can live without a car, got rid of this kind of car, and also got rid of the old heating system, going towards electric heating or heat pump system, electric cars, and that dramatically brings down, of course, that. But that's not enough, because the terrible thing is what I'm being here, and many of us are here, is the flying around in the world. So this is the air travel of our family. At the beginning, 94, that was mentioned when I was at the GSD in Harvard. I was a visiting professor. I was flying back and forth every week from Zurich to Boston. So that, of course, makes a big CO2 dent here. Then those were all the negotiations between Singapore and ETH, and had to fly back and forth many times. So you can see that reflected immediately. And so this is really the big thing that has to come down in the future for every one of us at ETH. And then the one big thing that what you can do about living in Singapore, doing all this research on urban metabolism, I thought I cannot go on like this. I have to compensate. I have to produce electricity to compensate for that. And here you can see the electricity produced and the avoidance of CO2 through the electricity production according to the Swiss system, and the mix with the German system, which is, of course, more coal-based still, gives a large reduction here. But still, you can see it's very, very high investment. There's about 1,200 square meters of photovoltaic to account for all the damage we have done to the environment before. Okay, but this is possible today, and therefore we think smart cities alone are not enough. We have to be responsive. We have to think ahead. We have to act. So smart cities today, they are characterized mostly by smart mobility, smart buildings, smart infrastructure. But how about people? Smart people, do they need to be smart? Sometimes it seems that companies or other people think that in smart cities, smart buildings, people do not have to be smart. And this is where we really object. Are these smart cities really interactive? Or is it like this? The first thing you enter when you get into a city, you drive a car and you're caught immediately by a flash and you get a speeding ticket, but you don't know, is somebody watching you? Is this just a joke? Do you get a bill later? Are they catching you later? So it's a very weird thing of a smart device entering a city, and you have this experience a lot when you go to Europe, maybe also in this country. But some cities, even city parts, compete how many they can catch and make money with this kind of speed traps. So this is not, I think, a very interactive or nice part of a city or a smart city. Then you have the smart cities that were mentioned before as well. You have Mazda, the so-called smart cities of Mazda, or here Songdo in Korea, where you see a lot of screens and very few people at the bottom watching many other people in many screens. And you think about the distance between the people of the city and the citizens themselves. So at the moment, it seems like smart city is the addition of big data plus information and communication technology, and this is very close to what Professor Lee defined yesterday. But there must be more. Already in the 18th century, and even before that, people were thinking, how can we make the citizens actually more happy in the city? So this is a book from 1749 by Mr. Ludovico Antonio Muratori, who wrote this book for his prince to make, it's about the happiness of the public. And he makes several proposals how to make people happy, not in a very stupid or very straightforward way, but very subtle way. Many of these things we can borrow from today to make people more interactive with their city and more happy with their city. And the point is we have to move the individual back into the center. We have to move the people back into the center and not the technology. Here, this is image from the Biennale in Venice from this year. And that leads us to the context, or to the concept of the responsive city. And the responsive city, this is not a new expression, has books about this already. But for us, we found this concept very, very interesting and define it as the addition of people plus the smart city technology. So taking command of the smart city technology, of the data, domesticating big data coming from smart city technology. There are examples for this that exist already, very good ones. It's not the entire city sometimes that are responsive. Sometimes it's just pockets within the city, like here Barcelona, or you could also take Boston from where the smart city, the responsive city book was coming. And one of the first things you have to do is to learn from the city what is going on. And that applies to every city. That's not dependent on the context, on the regional context. And then, and this is the important thing, you have to be able to give and allow for input. You have to give input into the city and allow for input in the city. So giving input is your personal courage, your personal responsibility. But allowing for input is also the responsibility of the governance of the city. If there is no platform, no receptor for your information, for your suggestions, it's hopeless. And that is why Jane Jacobs, that was also mentioned before, these problems, they exist since a very long time, actually since antiquity. But now for the first time, with the advent of these new platforms, I think we have the possibility to allow for input from the people. Here's a co-worker from us in Singapore, Dr. Matthias Berger, who has been trying to show to the Singapore government why it is so important and possible to cool down the entire island of Singapore. We also have to decide how we want to live. High density, like here, or how we can afford to live, high density like here, or low density and optimized for cars maybe at a certain point in history. Or if you want to live, like I showed before, in Zermatt in Switzerland, where there's no cars allowed at all. So this is the only type of transportation, plus the little electric trucks that they have constructed by themselves that we see later. With a small CO2 footprint. These things exist since 1946. They decided to throw out the cars of the village and build those themselves with batteries, and these are the only modes of transportation in this village. It's highly successful in terms of economics, ecologically, and so on. There are many contradictions we are facing in this development. So we know that each one of us long-term has a certain CO2 budget or limit per person. We have agreed in Switzerland that this should be maximum 1 ton of CO2. 1 ton of CO2 per person per year, but some people just fly for a few days to the Maldives and spend 5 tons of CO2 just doing that, just one flight. Just me coming here is just 5-6 tons of CO2 that I'm releasing. So this is one contradiction. And then we have these most livable cities in the world that I mentioned before. Vienna here, wonderful city, all kind of great feeling, people love it. But per person per year in this country, 7.35 tons are emitted. And you could name the same numbers for Switzerland almost, or for Germany. United States is about twice, and other countries are 3 times or 10 times as much. But these countries, we feel we are very responsive towards our environment. But then we go to other countries and we preach in schools and universities, like here in India, how to lead a sustainable life. And it's really kind of cruel, because in this country, people do use exactly as much as they could or should in the long term. So it really doesn't make sense. We have many, many conflicts in transmitting those messages. Also, the education is still quite elitarian. Here we have from our own university, from the ETH in Zurich, Yes, we have moved people away from the pulpit here. We have replaced it with with the screen, and the people are talking from below. But still, it's quite difficult to get into these schools. And how about all these people that we saw before, these billions of people who have absolutely no education and will not have the possibility for education? So cities must become more responsive, because if we keep all these conflicts looming, eventually they will blow up on us. Let's look at some of the reasons. Some of the reasons were already mentioned. There are 2 billion more people that will live in cities 30 years from now, and we do agree from our research that we do in about 22 cities around the equator that Africa will be the hotspot, and especially the city that was mentioned, Lagos, and these others are the hotspots in the next 20 to 50 years. Cities emit 80% of greenhouse gases. Industry is the biggest pulpit. And also transportation, mobility is second biggest emission of greenhouse gases. There have been attempts to solve many of these problems, also social problems, by designing cities from scratch. You know Chandigarh in India by Le Corbusier, or you see this one here, Brasilia, really designed from scratch to try to create a new world, a new approach, a new start. But it takes a long time until these things work. But we need approaches not like this, but analog to this in the future to restart certain cities in places where there are no cities now. We also know from history that it is possible to have top quality living with low environmental impact. Some cities have really accumulated a high art of living, but with very little ecological impact. We also know that cities can be built in very, very dangerous places like Naples, where there are earthquakes and volcanoes all the time, but it's very resilient, it's destroyed, comes up, resilient. Cities can deal with these situations. The one thing that we really have to be aware of and be careful of is of course, the social tensions that are created by the inequalities that are created through inequalities in jobs, in opportunities, and also in money. This is not the image from, I don't know, anywhere in the world. This is an image from Zurich in the 1980s, where there was really big social unrest, and this was the starting point of rethinking the whole urban design and urban development. Cities have become very complex networks now, and we can see it even now in normal publications and representations. And this is our big chance. I've become a huge fan of complexity science, and I think that really can help us to tackle these problems. So what is needed for us is innovation in city planning and management. Never before, and you saw the numbers before, never before have so many people lived in these cities. They have reached a size that is sometimes 10 times the size of a whole country of ages ago. So there must be a different type of city government coming up. How do we develop the city government? How do we develop this new city planning? Because we find out that city planning itself is one of the reasons quite often for the problems of the city 10, 20, 30 years later. And these are sometimes things that you cannot yet discover from data. We hope to be able to discover it from big data in the future. So this was our restart. Some of you might know this place, National University of Singapore, Department of Architecture, and this was our group of all kinds of people from different departments, from ETH, from Singapore, from other countries, and that was the start of our Singapore ETH Center, 2011-2012. So we have to take a few steps to come from smart cities to responsive cities. So smart cities, we can take the technology and the infrastructure as building blocks then for the responsive cities. And in responsive cities, we have to add citizens and their responsibilities. There is no way that we can just give more gadgets or give more this or that. It's not like in Roman times, bread and games. Really, citizens have to take their own responsibility, but they have to have the opportunity to take their own responsibility. How does that work? There are quite some good examples for that in the past. Resilient cities, you saw Naples before, this is Siena, very old, very rich city, even without green trees, but beautifully working. A very, very good local governance. This is the city in which the good governance and the bad governance is depicted in the city hall since hundreds of years. People must just look at it and they know exactly what they are into if they don't watch out, if they lose their good governance. And we have the example on the other extreme, Songdo, smart city, an example for the early development in this century, where companies built in smart city technology and then built the city almost afterwards. Or Singapore, which is quite important, and also Hong Kong in this context, we have a mixture of smart city technology and also people starting to act more and more towards responsiveness. So the instruments for responsive cities we propose to develop, one of them, our most important one, we call citizen design science, and of course responsive education. What is this? Citizen design science, it doesn't exist. You can look it up on Wikipedia, but it doesn't. It's just exactly one entrance where we defined it. But we have examples for that in the past. And I tried to, this is an example from the past in Florence, of course. Very nice combination, transportation going from A to B, protection, commercial, everything combined in one thing. It was not designed by grand architects, but by citizens. So we define citizen design science as citizen design, so that's what citizens actually do by themselves, plus citizen science, plus design science. And each one of them have a long history. So citizen design, you could say this is citizen design, this is a favela in South America, but out of pure necessity, citizens had to design these houses and this whole neighborhood by themselves, taking over the land, building these cities, building these buildings and streets and networks. It works. But you have other places, like here in Germany, hundreds of years old, 500-year-old houses designed and built by citizens with very simple materials, natural materials, adobe, wood, slate, that's it. And they have survived wars and wars and wars and fires and everything, invasions, bombings, and they're still standing. So this is citizen design, very, very resilient. Also in other places, like here in South Sudan, when you look at it from the landing plane, you can see how they build on the right, on the left, from lower density towards higher density. Or this one here in Ladakh in India, very beautiful citizen design, the monastery, the village, but not only that, but also the landscape, everything being in balance by necessity over hundreds of years. Or here in Myanmar, in Lake Inle, almost like Venice, buildings on stands and gardens, floating gardens, totally circular systems, easily destroyed now by influx of new technology. But also in high-tech countries like Switzerland, citizen design is not only buildings outside, it's also buildings inside. Here people making a makeshift concert hall in a wood factory just by using the staples there on the right and the left to improve the sound quality, and it has a fantastic sound quality suddenly, this place. Or, as I showed before, these little cars built in Zermatt since 50 years by local people, battery-driven, really citizen design of this time. The second part of citizen design science is citizen science. Citizen science, I'm sure you know about it here. There are centers for citizen science. There are examples for citizen science. The old encyclopedia are actually citizen science, or you could also say Wikipedia is a form of citizen science. Bird watching is citizen science, but also the definition of new galaxies and so on is citizen science. So that is a rapidly developing movement, but you can also see how people do that by themselves, makeshift installations combining technology and science to make this here in India, or in other places. And the final one is design science. Design science officially is there since the 1960s, but of course it's much, much, much older. Here, this is from the library of my friend Werner Oechslin in Einsiedeln, who has the best collection of all design science books from the very beginnings, from the 15th, 16th century, referring to design science treaties from 1,000 or 2,000 years old. And design science extracted rules being used to make beautiful places like this, design rules, or design science used for technology like our new, or not new anymore, but our first totally autonomous building up in the Alps in the Monte Rosa hut at 3,000 meters height, withstanding wind speeds of 250 kilometers and being totally cut off in winter. Or also our big campus, Science City campus, where we used design science to make the first and largest dynamic earth storage to carry over all the heat needed for the winter from excess heat in the summer. We combined all this knowledge or these experiences in our Future Cities Lab in Singapore. And that's where we actually want to develop this citizen design science, or prepare for the citizen design science to make it in a practical way. As you can see, this Future Cities Laboratory in Singapore is at the Create campus. It's between ETH Zurich. This is the main contributor, but then there are also researchers from EPFL in Lausanne, from Nanyang Technological University, from NUS, and from SUTD, the new university in Singapore. And we started with this quite simple urban metabolism idea, which is age-old, also from Rogers, this diagram in the 60s, in the 90s, excuse me. And understanding the city to behave as a dynamic and complex systems, and to read and model the system in terms of stocks and flows. So this is quite similar to the work that's been done in other places. We made examples for each one of these stocks and flows of people and of health, stocks and flows of water and of capital. This is again the storage lake that you see there, which is a battery at the same time, and a recreational space, making money, such as capital. Or stocks and flows of energy and materials, and stocks and flows of space and density, very, very important in Hong Kong or Singapore and all high-density cities. And stocks and flows of transportation and information, because there's a very, very strong relation between information, transportation, and the urban system. And one of the early works, a wonderful work by Kai Axhausen and his group on the urban transportation in Singapore, simulation, agent-based simulation, making an artificial population of Singapore and following almost every car around the different places, predicting where traffic jams may or may not happen. All of these things are possible based on data that are coming from the past. And this is one of the main weaknesses we see in big data. Yes, they might be even real time, but real time is old time in the next second. And architecture and design being a discipline, not a science, it always has to deal with the future. And you said just before, if we know what happened in Hong Kong last year, we know pretty much what could be next year. I agree with that. But in many, many ways, behavior of societies, behavior of cities are quite unpredictable. And this is where the responsiveness of city comes in. So all of this happens now in this Create campus. You see here the large number of people from all nations and all backgrounds, big discussions every week, models, physical models being built, computer models, so it's a really, really lively place, more than 200 people now. We do have big challenges, though, in these responsive cities, and I don't want to, not name them. And these challenges, let me list them up to you. We identified 11 big challenges. And the responsive cities overview here shows you the different projects that are part of it. So one of them is big data-informed urban design, one is cyber-civil infrastructure, one is engaging mobility, and one is perception, behavior, and cognition in urban environments. And each one of those has its challenges. Because, for example, in a responsive city, the inhabitants and the infrastructure constructively respond to urban challenges, changes, or disturbances. That's the important property they must have, capacity, competence they must have. Otherwise, the city will degrade and eventually die. Or a responsive city is the next level after the smart city, but with a human in the center. When we look at the history towards these responsive cities, this is very simplified, but if we go back a few hundreds of years, geometry-driven planning, sequential planning, functional planning, urban science, complexity science, informed design, and now big data informed urban design. It seems to be that from the design of the individual, it seems to move to evidence-based design and the design of the crowd. This is something we can say is good or bad, but that seems to be a clear development. And also we have to look at the challenges each one of these steps in between had. If you look, for example, at urban science, origins are really already in antiquity, but now ask Michael Batty, because he knows most about urban science now. Really fantastic source of information. Then complexity science, informed designs, stocks and flows was a very early beginning. But now ask Luis Betancourt, because he's your expert on this. When we come to big data informed urban design, we think that citizen design science and cognitive design computing will be most important issues to deal with. The reasons, again, the rapid urbanization as a major driving force, and the cities need to be more responsive in order to be more livable, because just by being smart, you don't create livability. The community spirit, the attractiveness, the wise reuse of resources, and the will to defend the city will make it responsive, then sustainable, and then resilient. And I must say, some of these findings are actually based on the very pure numbers of the Santa Fe Institute. Otherwise, or the other findings, or the other sources are really experience, or just looking at cities, how they are today, and how the resilient cities survived over all these years. But let's look at these 11 challenges now for the responsive cities. The first one is in cognition, perception, and behavior in urban environments. What are these cognitive, behavioral, and affective needs of people in cities, and how to support designers and decision makers to better anticipate human behavior and experience? That is very different in different cities of the world. Actually, it's different in every single city of the world. Here, Christoph Hölscher and his team are the leaders of that. Then, how can collaborative and interactive visualization support responsive urban planning and design? For some of us, diagrams say a lot. We totally understand them. We are excited about diagrams. For other people, it means nothing. For some of us, tables mean a lot. Others don't understand them. For others, text means a lot. Others don't understand it. They just understand drawings or something else. So we have to use the power of visualization more. Engaging active mobility. How can the cities respond to current and future mobility demands in high-density urban environments? Most of the transportation systems were made for not so high density. Hong Kong is fantastic because it has a high-density environment, a high-density transportation system, which is working quite well. And also cyber-civil infrastructure. How can we extend the lives of existing civil infrastructure by using knowledge of infrastructure response? All these fantastic bridges, tunnels, and so on built now, if we recover them or redo them after their normal lifetime, nobody will be able to pay for that. So we have to discover the reserves that are in there. How can sensors improve construction efficiency of geotechnical infrastructure? This will be a huge topic for the smart city, the responsive city of the future. And then how can we find hidden universalities in the dynamics of cities to predict further future urban developments? Markus Schlepfer, was mentioned before, is working on that with his PhD students. And that will be a very, very important work. And the nice thing about complexity science, that many of the complex questions suddenly become or get very simple answers, and that is quite encouraging. How can big data be used to enable predictive transport modeling to better respond to urban mobility challenges? This, of course, is related to transportation, but the link between transportation and urban planning becomes very, very obvious here. We have to establish this link much more closely. And then entering this whole new area of cognitive design computing. How can we combine the cognitive capabilities of humans with the computing power of machines? Still now it's quite separate, or one is serving the other. But working together is rarely happening at the moment. This is where we have to go. Reinhard König and his team, now at the AIT in Austria and at the FCL in Singapore and at ETH, is working on this. And how can we actively involve citizens to improve planning through the wisdom of the crowd in the citizen design science way? How can we integrate big data, user preferences, and designer knowledge for urban design and planning support to eventually and finally make urban design with what we find out from all these big data? Birgit Tunzer and her team are working on that one. And also, how can we make all the knowledge that we gain useful for, let's say, big tasks in a city? In Singapore, it will be to calm down, to cool down the entire city through science, not through air conditioning, and through planning. Here we have an example of the visualization, which is very, very important. Every step we do, we visualize and we make it available to all the other groups in the FCL, Future Cities Lab. This led us to the conclusion that Singapore is moving to become a responsive city. The example here is very clearly Tanjung Pagar, is this former harbor, which is supposed to be transformed into a new part of the city, a new city itself. And we know that a lot of work and investment and things are necessary to do that. But the city is really listening, it's outgoing to its citizens and asking them for proposals. At the same time, we are making proposals how to cool down the city. I mentioned that before, trying to go to the reasons why Singapore is so high in temperature, in humidity, in noise, in pollution. And we just have to add up the parts that we see here, the work that is done there that results as well into ambient heat, which is going into the atmosphere, and which is a quite normal way of things to happen. But rather than blaming people or blaming industry or something, we look at the sources. Where does it come from? This is then a part of science, comparing, for example, Switzerland and Singapore. Here on the left side, you see the energy incoming, the supply of energy. Here you see the energy demand. And you see in Switzerland, terrible energy incoming. This red part is crude oil. This is oil, natural gas, nuclear power, water power. And what comes out here, the majority of the energy demand is in transportation. That was my personal chart before. And then it's heating of the houses up here. And then it's industry, very small, only 19%. If you move to Singapore, completely different picture. All of the energy coming in is crude oil here and natural gas. And then in use, energy demand, almost 60% industry and only 5% in buildings. So you show how different these things are, and that means also moving towards a smart city, a smart energy system, a smart transportation system will have very, very different ends and means in these different cities of the world. And this is why I think, by the way, if Singapore's industry only got 10% smarter by using less energy, it would take up the entire energy needed for all the buildings, all the residential buildings. And also it could bring it ahead of Hong Kong, unless Hong Kong goes to the same chart and looks where it could improve. But it's always important to go back to the sources, to the roots of the problem. So this way, attacking these roots, we are planning to bring down the temperature in Singapore through planning, mainly through planning and through changes in governance within the next years. But again, we can do that because the city of Singapore is offering to its citizens new opportunities to live, work, and play, as they call it. And they put on the table possibilities how this new area could be done. They have 5 or 6 different possibilities, and they make it open. They don't do it secretly somewhere, make it open in the public. And this is very good. Okay, so the last 2 parts are on the responsive education and then what we should take home or could take home from this. Responsive education has to be inclusive, share knowledge, learn from feedback. I think this is, every education should be like that. It has been like this from the beginning. To be inclusive, it should be really for everybody. Otherwise, we cannot grow societies in a positive way. We have to share knowledge. That's the idea of education. And we have to learn from feedback. That was difficult up to now, but now there are really good tools to make this better or more convenient. Just simple examples from construction, for example, how to teach construction. This is from our site in Ethiopia, where we have founded the Ethiopia Institute of Architecture a few years ago with Ethiopian students that came to ETH to be trained and go back and do wonderful work. And this is a very convenient and very actually sustainable way of transporting concrete from level A to level B by donkeys marching up those ramps with the concrete on their back and pouring it on top of these buildings. And every single part of this can be reused. Then we have to think of ourselves and how we do even the simplest task, how much technology we need to do even the simplest tasks in our society. And this is really crazy, you know. You need a huge truck that lifts a little truck that lifts a little truck on a little piece of wall where then they move a little bit of earth from A to B. And just the amount of CO2 this is using just to construct this is mindless. But that's what we are doing, and this is what we're saying as progress. Sometimes very weird. Planning, very simple planning tools here. Again, Ethiopia can be used to make very competent building. These women here working with simple spreadsheets and simple plans for the construction of the whole area. Use of local materials, also here in Ethiopia, how we show how to build with local materials, higher density than they have it now. And then experience from Ethiopian students and young professionals coming back to Switzerland, telling us what they learned, what was good, what was not good, is also very important. This is a feedback loop that is always important. The other tool that is very promising, as was mentioned before, is the massive open online courses, MOOCs, which have really potential to democratize education. And by now we have developed a whole MOOCs series. It's called Future Cities and Livable Cities and Smart Cities, and this year we're starting on responsive cities. It's been translated into Chinese now and in Arabic as well, because that's where very big needs are at the moment. These are the countries that are participating, more than 170 by now. And you see also in Africa, there's quite, basically all the African countries, or people in all African countries do participate. Not so many yet, but especially in these areas where we have a high potential, are getting more and more popular. People participating. We developed these MOOCs from first broadcasting, just like it was normally done, getting out information. But then we got feedback more and more from these people. And we did not ask them only to do multiple choice and these kind of things. We asked them to send back images as answers to our questions. And then we got a flood, thousands of images, fantastic images that many of them have never been seen and that are being used now to teach the other students to learn from them. And then we developed the tool further into integrated teaching tool. That means our students are suddenly becoming the tutors of the students in the groups out there. So if there are 10,000 people in a course out there, they make little groups of 100, 150 people or 10, and then our students are the tutors for them. Sometimes it turns around and the students out there are smarter than our students, so they become the tutor of our students at ETH. So it's a very, very interactive development by now. And suddenly also we have new things we never anticipated before. Normally we always have research-driven teaching, but suddenly the tools we develop for teaching become research tools. So it almost turns around into teaching-driven research. This is for a project in South Africa, in the same neighborhood that you were showing before, Urban Shack project we call it. And we gave this site as a possibility for all the students in the MOOC to make proposals, design proposals with this design tool we developed for a browser. And the students use that quite a bit. And we will use the same tool now in Singapore for the population of the people living around this Tanjong Pagar area that's newly developed to make their proposals. So this becomes a citizen design platform. And as you can see here, we have a few proposals from our students at the top from ATH, and then hundreds and hundreds of other proposals from all over the world for the same site. So this citizen design platform becomes very active. And not only that, citizens can start to vote on their design, vote on each other's design. And such a process is very, very interesting because you have so much learning going on, so much discovery going on. And this is an opportunity we had never had before in this scale. So we are very, very excited about that. Okay, a few things to end up with. We believe that future cities must be livable and responsive. So these are our two major goals, and being smart is hopefully a good step in this direction. We have to give examples. So we start to design our own city, future city Zurich in 2100 in 80 some years, and we see the city structure is still there. So we have these predictions. We don't do the prediction in numbers, but we do the predictions always in space and time and physical structure of the city. And of course, the city is now zero emission, almost zero noise, different transportation systems is there, and many other developments that you can only recognize if you know Zurich. But the lake is still there, fortunately. We also think that responsibility is the foundation of responsive cities. There's no way that you can make a responsive city without responsible citizens. So that is very, very important. And it really doesn't matter where they come from, where they learn. These massive open online courses, they give the possibility to learn these things everywhere. That, for example, a young woman from Kenya learning through the open online courses what we do, coming to Zurich, educating herself, going back to Kenya. So these are the typical careers, I would say, of the future. We have to move in every city from complaining to designing, because many, many people complain about many, many things. Most of the people could design if they would be led to design. Propose things, design things like responsive parks, or take citizen design science serious. Everyone can do that to an extent, in different levels of sophistication. We have to learn how to negotiate. It's not enough to just propose something. We have to find ways, channels, how to negotiate. I can only say students are the best negotiators and the best people to find who to talk to when we move into a new city, no matter where it is on the world. Because students are the best ambassadors of ideas and of possibilities. Our advice to the governments of every city is to engage the citizens more. There is no sustainable city without engaged citizens in the long time. They know much more than many governments may believe. Our advice to the universities is to do independent research. Not so much sponsored research, independent research. That is also a matter of negotiation. How much independent research money you get to do independent research. In our university, you make sure we don't get too much in terms of sponsored research. So more than 1/3 is normally seen as not independent. Also, universities do design. I mean, this is a great place to do design here in Hong Kong. But there is much more freedom in universities to do design, to propose new design, than in many other places. So here, this is also an example from the Biennale, where our students did the design and construction of this. use big data to do design. I don't know who has been to the Biennale and saw our Swiss pavilion, but this is a cloud. It's not cloud computing. It's a computed cloud, or the materialization of a computed cloud put together in 3D printing, of course, with a specially developed concrete by Holcim to hold up this huge structure, which is almost the size of this space here. And as I said, we have to domesticate this big data, and this data coming from these machines. Robotic construction is an extremely important way into the future. Here we started quite small in Zurich at ETH with a little wall here up there, then building a building made out of walls constructed by the computer, then simulating a whole big space, a whole big new building to be built by the machine for building other one-to-one scale buildings with computers and robots. Then we built this prototype in Singapore in our Future Cities lab with small computers to small robots to construct small robots, small buildings or small models of buildings, of high-rises, new types of high-rises that would be difficult to materialize in other ways. And then moving to the one-to-one scale, also new construction types, patented construction types, printing, reinforcement, scaffolding, and concrete at the same time. And then moving to the big scale, this is only a matter of 3 years between the first and the last picture, building this actual building in Zurich, in Switzerland, in ETH, where the whole building becomes a huge robot. So this is the new robotic construction building we built for architecture, and you see the robots are not sitting on the floor anymore, they are coming from the ceiling, and they can touch any singular space in this entire space, huge space. A whole house will fit into that. They can 3D print it, manipulate it, move it, whatever you want, with an accuracy of 0.5 millimeters. And on top of this, of course, the entire roof is built by robots from a design that you just saw before. So this is what universities should do. They should demonstrate how it is possible to use data and big data in their design. And we use it, of course, for our whole Science City design already. For the citizens, we recommend to be responsive. This is great. This is an image just from the latest MOOC now on smart cities. One particular exercise, and we could see who was online on this exercise at a certain time, and you can see the time zone, day and night, and you could see who was giving which kind of input. This was for measuring the temperatures and the noise in these particular areas of the world. So if you can do that, it's great. But you also need government to be responsive to the citizens. So here we have the Swiss minister, Alain Berset. He is a responsive minister because he's listening to the Swiss ETH architect Christian Keretz, who is the author of this huge cloud design here, and he explains it to the minister. The minister listens and takes it up for his new ideas for his government. We hope so, at least. So the conclusion is, let us make our future cities the best and most responsive places humanity has ever built, lived, and worked in. Thank you very much.
Thank you very much, Professor Dr. Schmitt, for giving us an inspiring lecture on future cities towards which we should move. Okay, so I'm sure you have questions on the floor. So now we would like to open the floor for discussion. Questions? Okay.
It's not a question, it's more, not even a comment, but a reflection. I just text my president and try to ask him to come here to listen to your talk and basically telling him the kind of miserable resources that he has given us, our future city. Yeah. please minute it. How much money you have got? Don't answer.
We don't talk about it in Switzerland. That's not good. But it's enough to do all these things. And it's all coming through ideas. So that's important.
The real question is actually the shift of emphasis from technology to human, people, domesticization of data, and how citizens are empowered. And once they're empowered, we can forget about all this smartness that we think is governing the future. It's the people who will govern the future, and if they're centered in this whole debate, everything else is secondary. Is that the kind of message that you're trying to convince us? People.
That would be the ideal case, yes. But of course, we know people are also evil sometimes. They can use all of this to make very bad things with it. So if they are empowered, so use it to do adverse things, to destroy a city. It's very easy to do that. But I'm saying it's much easier to destroy a smart city without responsive people than if you have responsive people. And that is why I think, not being Swiss, I can say good things about this country. This is what's very good in Switzerland, because there, since 700 years, they have this direct democracy. Doing everything bottom up and not waiting for anything to come top down. They're very critical, anything coming top down. And therefore, they are really resilient. It took me a long time to understand why it is resilient. But it's really because they know, they use all of this technology. They don't talk about it very much. They use it all, but they use it for a certain end. And that is more livability.
Government's, Hong Kong's smart cities website and everything else. They seem to emphasize on ICT and all these other things. And there's no one section on the citizen. And that is, I think, is quite interesting of your talk.
Yeah, but I have to object. It's not true. In all the smart city descriptions, also in China, also in Hong Kong, also this part of the equation is in there as well. But most of the time, people only talk about technology. Interesting enough, the definition of a smart city in the European Union, if you compare that one to the one in India, 10 criteria. For example, in India, even in India, the responsive citizen or the participatory citizen is much in a higher position than in Europe, because they take it just as given. So that's why it is in different places differently located. But it is in there everywhere. But I think it's important to bring it in by more forcefully now. And the smartness of a city. The smartness of a city is an important precondition to do that. And the knowledge we gain from complexity science and all the other research is an important foundation for responsive citizens. Without that, it's still, is belief and feelings, which are important, but it's not as evidence-based as it could be.
Test. Yeah, we're coming here for the smart city, but then we got a responsive city, sustainable city, as well as the resilient city, as you mentioned. So my first question is, could you give a short description on the states of difference between these four types of cities? The second question, we notice you have mentioned for a responsive city, the role of the government, from the education, students and citizens. But for a society, we also have other sectors, such as manufacturers, industry, business people. So what are their responsibility in this responsive city? Thank you.
The differences that you asked for between these different levels of city definitions are additive. So, and they are not emotional, but they just a goal definition. So if you define that you want to be sustainable with a city, we think that you need to be responsive. Being smart alone is not enough. So the sensors, you have to install them, you need them, but they by themselves, even with the software installed, is not enough. You need people who understand what they are doing, and you need people who want to support that they do what they're supposed to do. Because otherwise these sensor networks will degrade after a while. And the only sensor network that will be there for a long time is the one carried by people, is the smartphones and all of those, because they're maintained by the people. But we need the people's consent that they give us all the data, the big data, that we need to run a city responsively. So that's the difference. So I would say the city needs to be smart, but you have to have the goal, and the goal must be supported by the people of the city. And this goal that can be the same for many cities, but how you achieve that is different in every city. Then the second question concerning, I was only talking about the people. Who are the people? These are the citizens. We think, and I come again from the Swiss example, in Switzerland, everybody is a citizen. So even as a high military person, you are a citizen. You are military for a while, or even as a professor or whatever, the so-called Milizsystem. So you do all these tasks for a while, and then you give them back, and you become a normal citizen again. So in your responsibility as a citizen, you do run your company or run your business or whatever. So it shouldn't make a difference. And the goals between the society and the business people should not be different. But you see, this simple chart I showed between the energy system in Switzerland and in Singapore is very, very telling. Because seeing this chart, I decided I can do something. Because seeing this chart, I saw suddenly that the individual person, just by 36% of all the energy being spent by driving cars in that overall country, and by 27% heating houses, that means 27 plus 36% is controlled by me as an individual. I can do something about it. Whereas in Singapore, I suddenly saw 60% is by industry. So the actual percentage of activity that an individual can do to reduce CO2 output is reduced. And that is why industry and the population have to have the same goal.
I agree with your the comments on the responsibility of individuals, but for the different sectors, I have a different opinion from you, because if you look at the such as the factories or business people and the other sectors, the goal is different. So. As we have observed from the reality in the world, we see they have much different, I think, in the idea of how a sustainable future is. And maybe some of them, they don't care about the energy issues or the carbon issues.
I agree. It looks to the outside that there is a contradiction between the goal settings of industry and people, but I would still claim that in Switzerland the contradiction is very small. And the numbers also speak for themselves. Switzerland is the #1 country in competitiveness and in innovation worldwide. So how does it cannot be a contradiction. I'm convinced if you bring those goals closer together, you will be more successful as a country than if you have these great differences. But it's hard. I agree.
Yeah, I think Switzerland, the cities are relatively small. So for Singapore, like Hong Kong, and high density, large populations, do you think is there any possibility such kind of city can also be zero emission cities in future? Make the bigger cities zero emission cities.
Yes, I'm totally convinced. Of course, the ideal size of the cities for this type of efforts in the countries that we are talking about, or the range of countries we're talking about, is between 2 and 5 million. When it gets bigger, then it gets more difficult. But it is possible, yes. But of course, in terms of Singapore, the electricity that's needed to run the whole country at this point cannot be produced in Singapore itself. Then you need to negotiate with the neighboring countries. I mean, you have 80,000 square kilometers of palm oil plantations right next door. You would only need 500 square kilometers to produce the entire electricity for Singapore. Tiny, tiny fraction. But this is a matter of negotiation to do that. And Hong Kong and many other cities would be the same.
If you know much about the other group's research on responsive or sensitive sensors for infrastructure, what type of sensors, what type of innovative sensors are we talking about? Since we've had a lot of traffic type of sensors for the last several decades, and what type of actuators, perhaps, to alter those traffic is the group thinking of?
Sensors are mostly placed because they are available or they are really needed. And I know when I was responsible for the whole infrastructure of my university, we put in about 60,000 sensors in all kinds of technical systems. But that was on a need base, where we thought they were needed. The fact was that after 3-4 years, nobody even knew where they were anymore and what they did, and ran out of power. And so you will have the same situation there. And so this is my experience. Maybe it gets better in the future if they are self-powered or solar-powered or whatever. But I think only those sensors that are really needed, and then you don't need so many, and those sensors that are carried by people will be the ones that are used. And the ones that are carried by people, then of course you need their consent that the data they send are collected. And this is great, because then people can actually control the data they want to give, because they become part of the overall system and they are not just monitored as objects or subjects by somebody. And these sensors that are needed, they are really, really helpful, especially in infrastructure, in the cyber-civil infrastructure, because there we can make sure that these sensors guarantee safety and so on. But 2-3 PhDs of our people in Singapore are focused on the specification of the best places and the smallest number of sensors to achieve the same results as with many, many sensors. This is optimizing the number and location of sensors is a big topic.
The problem is that the city has too many objectives, too many goals. I guess satisfying all these objectives may be the biggest challenge.
It doesn't matter because the goals, I mean, you have one big goal maybe, but that will not last forever. Every government changes goals slightly every few years or even faster. And again, in Switzerland, we have the system of voting all the time. You know, the population is voting every 2 or 3 weeks sometimes on something. So it's a continuous process. It never ends. It's really a process. And once we recognize it's a process, a continuous process, also then decisions are not that harmful anymore. Once you make a wrong decision, you can return it. So, you know, especially big cities, big countries cannot be, you know, going for hundreds of years in one direction. That has never worked. I think the process of making decisions has to change, and of accepting how to change decisions and how to arrive at a common objective.
Okay, I think the big data-informed urban design may be a good direction for the future of this discipline. But my understanding is the current training in urban design and architecture really emphasize individualism and their own style, own design. And do you think in the current education, tertiary education, we should have some change in the curriculum to change urban designers and architects' mindset to embrace this wisdom from the general?
It's awfully needed, yes, absolutely. But
how to change this industry or these disciplines?
I don't think it's difficult. I mean, that's what we do with these MOOCs, and then people are very interested from industry, especially to get in and to also to listen to that and to make their proposals. But if you have an old style curriculum like we also had, it's very difficult because you teach a very small number of people for a very specific part of the world. And if you send them to another part of the world, it will end in a disaster because the conditions are so difficult. That's why we decided we will not teach in Singapore. We will just listen and do research. And only after 5-6 years, when they ask us, we start to teach 1 or 2 courses here and there. I think it's necessary. We cannot do this old style teaching of urban design for other places. For our own city, we can do what we want. But for other places, in a globalized world, this is very dangerous. In the globalized world, I think we have to come to this process of negotiation, of defining goals, and then move towards... we have to also see what kind of transportation damage one planning decision can make. Now it's always done in different departments, but if we run like in our simulation platform, at the same time the simulation of the planning and of the transportation, you can see immediately what kind of damage you can do to an individual person's life if you make a certain functional description of a part of the city which is too restrictive or too loose. And this type of simulation we have to have real time. Everyone in the city has to be able to do and to see that on their smartphone. And the software is available and will be used by many people.
Okay, for the interest of time, one last question. So we can have discussion later on this afternoon. Oh. 2 then. Okay, I got 2 hands. Okay.
Thank you, Dr. Schmitt, for bridging up the being smartness and being livable. In fact, I'm studying sustainable tourism in the CUHK. And is there any large-scale effort so far you acknowledge that have been done to integrate the smart technology to tourism, especially on the aspect of cultural and heritage, the side of tourism? For example, Singapore, in Switzerland, or any other part, you apply technology, smartness with tourism.
I would say in Singapore it's very prevalent, more than in Switzerland. In Switzerland, don't see much of this, but in Singapore, it is a goal actually. Yes. We don't know how effective it will be, but it's the goal. Yeah. That was the last. Okay. Oh, you had the last, yeah.
Yeah, thanks for introducing this kind of responsive cities idea, and also let us know this your successful experience from the Switzerland and also from Singapore. But the problem is now we are in China. We are facing the developing countries, so that means the problem or issues are more complex than the Singapore or Switzerland. This kind of well-developed countries. And in your PPT, you mentioned that almost the livable cities have efficient local good governance. I quite agree with this point. So what is your opinion if the China, the government, they want to do this kind of smart city, the role of the governance in this kind of city development?
It's just always important to have local good governance. And that also is, I think, an answer. Is it possible in a large country, yes or no? Yes, it is. Because in the end, the governance of a city is always local. It could even be a district. If one district is governed in a good way, using giving people the opportunity to do that, then it will spread from there. I'm absolutely convinced. This example that it originated from in Boston was also a very small example, and from there it's now used in the entire city, because it makes government. Sometimes people criticize government, but many times they don't understand why they make those decisions. If the government knows more what the people actually are worried about or want, then the decisions of the government will also change. I'm convinced. I've always seen that happen. I've seen it happen in every single city I've lived in, I must say.
Except China, of course.
I have not lived in a Chinese city.
Okay. Please join us to thank Professor Schmitt for giving us such forward-looking lecture.